myself Maninder Kaur, lecturer chemistry. Today my topic is subatomic particles and Rutherford's model. Who knows what happened? During the final stages of World War II in 1945, the United States conducted two atomic bombings against the cities of Hiroshima and Nagasaki in Japan. By the executive order of President Harry S. Truman, US dropped the nuclear weapon Little Boy on the city of Hiroshima on Monday, 6 August 1945, followed by the detonation of Fat Man over Nagasaki on 9th August. These two events are the only active deployments of nuclear weapons in war. This is the picture of the Fat Man mushroom cloud resulting from the nuclear explosion over Nagasaki. The picture of mushroom cloud over Hiroshima after the dropping of Little Boy. The birth of the atom. The word atom comes from the Greek atoms and signifies indivisible. This notion was invented by Leucippe of Milet in 420 before JC. Ideal qualities. First is invisible because of their extremely small size. Second, indivisible as their name indicates. Third, solid, no void inside. Fourth, eternal because they are perfect. Next is surrounded by an empty space to explain their movement and changes in density, having an infinite number of shapes to explain the diversity observed in nature. In the beginning, actually, the thought about electricity came before atoms. In about 600 BC, Thales of Milet discovered that a piece of amber, after rubbing it with fur, attracts bits of hair and feathers and other light objects. He suggested that this mysterious force came from amber. Thales, however, did not connect this force with any atomic particle. Not until around 460 BC did a Greek philosopher, Democritus, develop the idea of atoms. He asked this question: if you break a piece of matter in half and then break it in half again, how many breaks will you have to make before you can break it no further? Democritus thought that it ended at some point, a smallest possible bit of matter. He called these basic matter particles atoms. Dalton's theory. According to this theory, atom is the ultimate particle of matter and it can't be subdivided. According to this theory, atom is the ultimate particle of matter and it can't be subdivided. Second is all matter is composed of atoms. Atoms can't be made or destroyed. All the atoms of same element are identical. Different elements have different types of atoms. Chemical reactions occur when atoms are rearranged. Compounds are formed from atoms of the constituent elements. Picture of atomic theory proposed by John Dalton. Properties of Dalton theory. First property is matter consists of definite particles called atoms. Matter consists of definite particles called atom. Second, atoms are indestructible. In chemical reactions, atoms rearrange, but they do not themselves break apart. In chemical reactions, the atoms rearrange, but they don't themselves break apart. Atoms of one particular element are all identical in mass and other properties. Atoms of one particular element are all identical in mass and other properties. When atoms of different elements combine to form compounds, when atoms of different elements combine to form compounds, new and more complex particles form. However, in a given compound, the constituent atoms are always present in the same fixed numerical ratio. Picture of John Dalton, who proved atomic theory, law of multiple proportions, Dalton's law of partial pressures. What are the drawbacks of Dalton's atomic theory? First is, it could explain the laws of chemical combination by mass, but failed to explain the law of gaseous volumes. Second, it could not explain why atoms of different elements have different masses, sizes, and valencies. Second point is, it could not explain why atoms of different elements have different masses, sizes, and valencies. Third is, it could not explain how and why atoms of different elements combine with each other to form compounds, atoms of or molecules. It failed to explain the nature of forces. It failed to explain the nature of forces that bind together atoms in a molecule. It gave no satisfactory explanation between the ultimate particle of an element and that of a compound. Modern atomic theory, it has been found that atoms are also made up of three subatomic particles: protons, neutrons, and electrons. Atoms are made up of three subatomic particles: protons, neutrons, and electrons. The atom has a nucleus made up of protons and neutrons. Nucleus has protons and neutron with electrons orbiting around it. The internal structure of the atom allows us to understand its properties. Because protons and neutrons are in the nucleus, they are sometimes collectively called nucleons. Protons have a mass of approximately 1 atomic mass unit and have a positive charge. Neutrons have a mass of approximately 1 AMU but no charge, that is neutral. Electrons have a mass of approximately 1 over 1836 AMU and has a negative charge. Protons repel each other and electrons repel each other because of identical charges, keeping them spread out throughout the volume of the atom so that the repulsion do not split the entire atom apart. Protons and neutrons have opposite charges and therefore attract each other. This attraction holds the electrons around the nucleus. Fundamental particles. About 35 subatomic particles are known, but three particles, electrons, protons, and neutrons, are regarded as fundamental particles because these are the main constituents of all atoms. Production of cathode rays. J.J. Thomson found that an atom is not the ultimate particle of matter, but it has still smaller particles. He took a hard glass cylindrical discharge tube. This is a hard glass cylindrical discharge tube fitted with two metal electrodes. It is a hard glass cylindrical discharge tube. It has two electrodes. One is cathode and other is anode. On passing high voltage current through the tube, the low pressure gases become conductors and electricity begins to flow in the form of rays. These are called cathode rays. These rays, they are known as cathode rays. These rays, they travel in a straight line at right angle to the surface of cathode. Cathode rays cast shadow. Cathode rays travel in a straight line at right angle to the surface of cathode when an object is placed inside the tube. It casts a shadow. This is the shadow of matter. It casts a shadow on the wall opposite to cathode. Thus, rays travel from cathode towards anode. Mechanical effect. Cathode rays produce mechanical effects. For example, small paddle wheel is placed inside the is placed between the electrodes. It rotates. Small paddle wheel, it when it is placed between two electrodes, it rotates. This shows cathode rays consists of material particles. Cathode rays rotate the light paddle wheel. Heating effect. When cathode rays are allowed to strike a thin metal foil, it gets heated up. Thus, these rays possess heating effects. Electric effect. Cathode rays are deflected towards the positive plate of electric field. Discharge tube is modified by adding a pair of metal plates. When these plates are given opposite electric charges, the beam of cathode rays are deflected towards positively charged plates. This shows that cathode rays carry negative charge. Properties of cathode rays. Cathode rays bring about ionization of gases through which they pass. They produce X-rays when they strike hard metals like tungsten and copper. Cathode rays produce X-rays when they strike hard metals like tungsten and copper. Cathode rays consist of negatively charged particles which were named as electrons. What is electron? Electron is a negatively charged subatomic particle. It can be free or bound to the nucleus of an atom. Electrons in atoms exist in spherical shells of various radii, representing energy levels. Electrons in atoms exist in spherical shells of various radii, representing energy levels. Larger the spherical shell, higher the energy contained in the electron. What is an electron? An electron is defined as subatomic particle which carries 1 unit negative charge. An electron is defined as subatomic particle which carries 1 unit negative charge and a mass equal to 1/1837 of that of hydrogen. This is electron orbiting around nucleus. Charge and mass of electron. J.J. Thomson found that the ratio of the charge to the mass E by m to be same for all cathode rays. The ratio of the charge to the mass is called specific charge. The value of E by m is 1.76 into 10 to the power 8 coulomb per gram. Charge on each electron is 1.6 into 10 to the power minus 19 and mass of an electron is 9.1 into 10 to the power minus 31 kg, which is 1 over 1837th of that of hydrogen. Anode rays. Electron is a universal constituent of all matter, suggests the presence of positively charged particles within the atom because atom as a whole is electrically neutral Goldstein confirmed the existence of positively charged particles. Origin of anode rays. Goldstein took a discharge tube fitted with two electrodes, cathode and anode. It has a side tube. This is a side tube with the help of which air can be exhausted. On passing high voltage current, rays starting from anode perpendicular to its surface appeared at the back of cathode. These rays were found to have positive charge. These rays are called anode rays. Properties of anode rays. Anode rays travel in a straight line at right angle to the surface of anode. These rays move towards cathode. These rays consist of material particles and rotate the pedal of wheel when placed in their path. These rays are made up of positively charged particles. Like cathode rays, they also produce heating effect when struck against the metal foil. The magnitude of charge on the positive particle varies from one particle to other. The magnitude of charge on the positive particle varies from one particle to other depending upon the number of electrons lost by an atom. The total charge on each particle is either one unit positive charge or some whole number multiple of it. The mass of positive particles depends upon the nature of gas in the discharge tube. Glowing of glass at the anode. Cathode rays produce green fluorescence on the walls of glass. The glass tube at anode end begins to glow with a greenish light. The glowing of tube, the glowing of tube is due to the bombardment of glass by certain rays emitted from cathode. The glowing of tube is due to the bombardment of rays emitted from cathode. Protons. What are protons? A proton is defined as a subatomic particle which carries 1 unit positive charge and mass nearly equal to that of hydrogen. Proton, it is a subatomic particle which carries 1 unit positive charge and mass nearly equal to that of hydrogen. Protons are positively charged atoms that reside in the nucleus. These protons add the overall positive charge of a molecule. Charge and mass of proton. The ratio to the charge to the mass of anode rays E by m is not constant but depends upon the nature of gas. E by m of anode is 9.58 into 10 to the power 4 coulombs per gram. M is equal to 1.67 into 10 to the power minus 24 grams. This mass is nearly same as that of hydrogen but is 1837 times the mass of electron. This positively charged particle is known as proton. Thomson's atomic model. J.J. Thomson in 1898 proposed that positive charge, this is positive charge matter, positive charge is spread over a sphere in which electrons are embedded to make atom as a whole neutral. This model was much like the seeds embedded in a watermelon or plum in pudding. His model of atom is called plum pudding model. Rutherford's scattering experiment. The concept of J.J. Thomson was proved to be wrong by scattering experiment of Rutherford. A narrow beam of high-speed alpha particles emitted from radioactive element were directed towards a thin sheet of gold. A movable screen coated with zinc sulfide were placed at the back of black sheet to detect whether the alpha particles undergo any deviation in their path or not. Observations. Most of the alpha particles passed straight through gold foil, 99%. Some of the alpha particles were deflected by small angle. A very few alpha particles suffered large deflections more than 90° and even came back in the same direction. Conclusion. Most of the atom is hollow. The central portion of the atom carries positive charge which repels the positively charged particles. The central portion of the atom carries positive charge which repels the positively charged particles. The central portion of the atom is solid and carries nearly